This is Fan of Astronomy, Episode 6.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome, everybody, to Fan of Astronomy. And Dan's here this week.
Hi there.
How about that? He actually woke up.
Yeah, this time I did. I'm very sorry for last time.
Well, you know, we got to rag on you a little bit. Just for those who might be listening for the first time, I am one of the hosts of the show. My name is Angelo. That other guy is another one of the hosts of the show. That is Dan. He was absent last week, and it was the week that we had an astrophysicist on, which is just mind-boggling that he would miss that.
Yeah, but I was pretty impressed with the episode. You did a great job, as did Aaron.
Yeah, you know what? It was really easy to do. All I did was ask questions and shut up. It was like, go ahead, talk. All right, yeah, okay, yeah. Like, I got to the point where I was like, should I just say something here? So I would add little stupid things that popped into my brain, and it's like, yeah, it really wasn't needed. But, oh, well, I'll leave it in.
Yeah, it was great.
I always enjoy having clues around. If you haven't listened to that episode, I recommend, if this is your first episode, that you go back and you listen to our 5th episode with astrophysicist Aaron Lockley. It was a great episode, and it's just a shame that Dan couldn't wake up.
I blame the Atlantic Ocean for putting these many time zones between us.
It's only, 6 hours?
Yep.
Yeah.
Turns out that getting up at 3 a.m. is rough.
Yeah, but I do it every week.
Yeah, but we have very different day cycles.
What do you mean? Mine's a good 16-hour day right now. I mean, it's winter.
Yeah, but it's not the same 16-hour day as I have. I'm a morning person, you're an evening person.
Not really. I'm just a don't-sleep person. I mean,
zombie person.
Yeah, when you only sleep 2 to 3 hours a night, it does help with the I feel like getting up at 3 a.m. to record thing.
It does.
So we do have some changes that we're going to make to the show. These came about because last week after the show, or last episode, not week, yeah, after the show with Clues, I did some talking to him, and, you know, he kind of critiqued the show because he had listened to a few episodes, and he gave me an idea. And that idea basically is try to tell instead of going point, which we kind of have been doing, but part of that was because me and Dan's been developing our chemistry a little bit. He said it would be better if we could tell a story with it. And I said, you know what? I can tell a story. That's not a problem. So what we're going to do is we're going to try and do this more in a story format where we don't just go, hey, this cool thing happened. And hey, this cool thing is going on there too. We're going to try and weave things together so it almost sounds like we're segueing from one topic to the other. The one thing, though, is with the expansion of this, we cannot guarantee that we're going to have news in every episode unless it's really, really important news.
Yeah.
Mainly because with the addition of the story and what have you, it's going to expand the length of the shows. And me and Dan made the commitment very early on. We're going to keep these between an hour and a half unless our main topic's content makes it longer. Then we just do what we got to do. Today, we're going to go over the moon, which, I mean, this could be a 6-hour episode.
Easily.
So what we're going to do is we're going to go over some, you know, the main points of the moon, and then sometime in a few years we're probably going to come back to the moon and talk about other things about the moon because we don't cover it all. We don't even get close. Hell, I don't even think we talk about the other side of the moon being thicker in this one.
We don't.
No. So there's one of the things we don't talk about. But Dan?
Yes?
Since I haven't podcasted with you in forever now.
Yeah. For so long.
Yeah. Do you remember that we have a Patreon?
Yeah, I do.
You should tell them about it.
It's at patreon.com/astronomy. Patreon is a tool for podcasters and creators of regular content to get sponsored by fans that really love their work, as you love this, don't you? And so you commit a dollar value for an episode. So you say, I will give you $2 an episode, for example. And then if we make an episode, we get $2 from you. If we don't make an episode, we get nothing. If both of us oversleep and there's no episode, you don't have to pay anything. And if we reach certain levels on the Patreon, you get, we reach goals and good things happen. For example, if we can get sponsored by $700, we will deliver Final Astronomy every week. And if we can get to $100, we will deliver a bonus episode about how the universe wants to kill us. Because it does.
It very much does. And at every $100 milestone we reach in between $100 and $700, we will give you another episode. Well, we just haven't come up with the topic yet, but we're going to come up with neat, interesting ones, and that'll be our intermittent episodes there. But the $700 mark is really where you want to get us, because at that point, I have to dedicate my life to this show, apparently.
Yes.
It'll be a lot of work, but you know what? That means at that price point, it becomes worth it.
Yes.
Because by the time me and Dan... Go ahead.
I work with Patreon for several other podcasts that are more mature than this one, in that they have run longer. And it's a really great tool to keep in touch with the really dedicated fans. So now at the end of February, I'm going to have a dinner and drinks event for the followers of Palmemordet, my podcast about the murder of the Swedish Prime Minister in 1986.
Okay, yeah. I was going to say, like, at the $700 mark, the reason we came up with that number, it's not like an arbitrary number. It'll be every week we do a show. So what that'll do is that'll give me and Dan both $350 before taxes every week. But the thing is, at that price point, we'll reach a spot where it's well worth us going ahead and saying, you know what, every week we're going to do this. This will be our number one thing on our schedule each and every week, because it is creating a living for us, right?
Yes.
So our main topic for today is the moon, and I would like all of you to go ahead and let us know what you think about this change on any of the media sites that we're located. So let's begin. Our moon is like no other moon in the solar system. What the Romans used to call Luna is truly unique among the more than 150 moons in the system. From its makeup to its size to how it's made, nothing we know is quite the same. Over the next half hour to an hour, we will explain how different and strange our moon is. It starts at Mother Earth. We've called it that for as long as anybody can remember. We call it that because it's the giver of life to us. But in fact, the Earth actually has a child, and it's not us. It starts roughly about 4.5 billion years ago, as the Earth was floating alone through space. Then a father named Theia came into the picture in an explosive way. Theia crashed into the young Earth, and like a praying mantis, after the deed was done, it was swallowed whole by the Earth. But the seed was planted, and shortly later, a baby girl named Luna was born.
There was a conference in 1984 where clever people were discussing the origin of the moon, and there were three hypotheses before the conference and after the conference. This giant impact theory won out and is the number one theory today. There is a list of evidence why this happened and why we believe this is the way the moon was created. Perhaps we should note that the impact between, as we discussed in episode 1, the impact between Theia and Earth was very special. It was the perfect blow. It would have been easy for us to get totally destroyed, and no Earth, no Theia, no nothing, just an asteroid belt with some dust. But that didn't happen because Theia hit us at exactly the right angle. So, what's the supporting evidence? We have a similar orientation between Earth's spin and the moon's orbit. We know from samples of the moon that the moon surface was once molten, probably as a result then of this giant collision. We know that the moon has a relatively small iron core. We also know that the density of the Earth is extremely high for a rock planet. It's the densest planet in the solar system. And that's because the lighter parts made up the moon and the heavier parts stayed with Earth 2.0 then after the collision. The moon has much lower density than the Earth. It's still pretty dense for a moon, suggesting maybe that it didn't form in the sort of regular way the moons of the solar systems form. That is, they just come together because of gravity around some body such as Jupiter. We do have a period of heavy collisions in the solar system where stuff like this happened all the time. If we look at the stable isotope ratios of lunar and terrestrial rock, they are identical, which implies a common origin, but it could also lead to some problems we'll talk about later in this show. Do you have anything to add on the impact theory?
No, you about nailed it all there. Yeah, I would say you hit it. So, moving on. just like any other child, the moon has been drifting away from its parent. I mean, who wants to sit there and live next to mom for the rest of their life? You could say that the mother, though, is kind of pushing the child away. The tidal interaction between the moon and the earth pushes it a little bit each year. The substance of life itself, water, is actually what seems to want the moon gone. And it kind of makes it actually impossible to have a forever locked moon. But don't worry. Calculations state that it's going to take about 50 billion years for the moon to leave the Earth's orbit completely, and that's well after the sun expands. From there, besides, all bets are off. We have no clue what gravitational forces with the moon, with the sun expanding, is going to play on us, is going to play on the moon, is going to play on other things in front of us to maybe push us further out. We have no clue. We have ideas, to be honest, but nothing is set in stone, because with each generation, we can't imagine the breakthrough scientifically that the next generation will have, and new data will always bring about new hypotheses.
So what would happen if, say that the sun was stable and stuck around?
Yes.
And 50 billion years went by.
Yes.
So the moon would just
Take
sort
off.
of drift away from us.
Yep.
And become a planet, right?
I would think as
Or a
much.
dwarf planet at least.
Yeah, I mean, I would think it would drift away from us, eventually get caught in the sun's orbit once it left
It's
ours.
bigger than any of the dwarf planets.
Yeah, oh,
which
yeah.
is quite interesting.
Yeah, it would get it stuck somewhere in the orbit between us and Mars is the highest probability. However, it could get stuck between us and Venus as well, and it would just settle into its own orbit and become a planet itself. But that would take forever from now, and we know it's not going to happen.
I wonder if it would go for like Theia Part 2 and crash into the Earth.
It very well could, but doubtful. It has a higher probability of actually crashing into one of our neighboring planets than it does us, because we're kind of the center lever of force. And you think of us spinning, we're going to shoot this thing off, and because we're the center lever, it's going to leave us. It's possible it could, get fired directly into Mars or directly into Venus, depending on, where the orbits of those planets are at said time, but more likely it would just end up settling out between the two gravities of the two, close major planets, and the sun would grab it and it would find its own little home in between.
That's kind of beautiful.
Too bad it's not going to happen.
No, the sun will see to that.
Yeah, and it's pushing away about how far a year, Dan?
It's about 4 centimeters, or numbers vary because it's not a constant rate, but 2 inches for your US people.
Yeah,
a year.
Yeah, I've seen further projections, and they say as the moon gets further away from us, it will pick up the pace. So
It's still pretty slow.
Yeah, it's still pretty slow at leaving us, but because it gets pushed a little bit further away from us each year, it goes ahead and does that. And the reason it can't be a steady rate is because of the tides and because of our own temperatures here.
Oh.
Believe it or not, the tides do move water, crazy water. And what happens is the moon comes whipping around and the tides begin to push up, and then the tides let go and the moon kind of gets pushed. Imagine the Earth is like a little ball and you're squeezing it at the tops, and the tides are kicking out. So that pushes the moon out just a little bit.
Also, the tides have these effects on the moon's surface as well, but we can't see it as clearly because it's not water.
Right. But the thing is, when I say our temperatures, that plays a role because the tides don't interact as harshly with ice as it does with, liquid water. So, when we talk about global warming and climate change and things like that, that actually is pushing the moon out a little quicker.
Oh no! The moon is also slowing down the rotation of the Earth.
Oh, very much so. If it wasn't for...
That's why we have 24-hour days today.
Yeah, it would be like 6 hours without the moon.
Amazing.
Try getting all your work done in a 6-hour day and getting to sleep. 'Cause
that would be so stressful.
I mean, biologically, you'd think that our bodies would adapt to the 6-hour day.
That would be weird.
That would be very strange. I can't even fathom that. It'd be like, get up, go to work, come home, go to bed.
You would have to work very close to where you lived.
Yeah, there wouldn't be these hour commutes, that's for sure. So the tides are basically what, Dan? Just kind of a gravitational thing, right?
Yeah, gravity doing its thing.
Okay, so we've gone over the large impact theory, but there's another hypothesis about how the moon was born, and it's a new one. The Weizmann Institute of Science recently released a new hypothesis. An impact is still the main part of it, but instead of one gigantic hit, they propose a series of large hits. We know of the Great Bombardment, and this theory seems to have some solid ground in which it derives from.
Yeah, it does.
Yeah,
The big problem with the giant impact theory with Theia is that Theia should not have the same composition as the Earth. Theia should be somewhat different, and Theia should not distribute evenly between the Moon and the Earth. So there should be a difference between the composition of the Moon and the composition of the Earth, but the Moon and the Earth are too similar.
right.
So there is a suggestion then that the Moon is made up of stuff almost exclusively from the Earth. It's like a big nail in the eye of the giant impact theory.
True. I mean, they're saying that, instead of one huge one, we're talking about maybe 20 really, really large impact collisions. And when I say really large, I mean, kind of bigger than the ones that destroyed the dinosaurs. A lot bigger. Yeah. So, but I mean, it kind of makes sense. There is some firm ground when you think about, the early bombardment, the early heavy bombardment and the late heavy bombardment. I mean, we know that these things happened.
Yeah, we do.
So it's highly possible that this theory holds some pretty good ground, but it's only a hypothesis, a hypothesis at this point. So there definitely needs to be more study on it, but we thought we should let you know about it because this could change the way we think about the Moon being born in the next 20 to 30 years.
One obvious problem then is if this happened to the Earth 20 times, it should happen to other planets. And of course the gas giants will just consume any rocks flying into them. But we have a very similar planet to the Earth that we talked about in the last episode, Venus. And Venus doesn't have a moon, and this should have happened to Venus too. So maybe Venus' environment is special, maybe it's too close to the sun for this to happen, or Venus has lost moons, or a moon.
Which is possible.
Yeah, but it's still like something that needs to be answered for this theory to work.
Yeah, it's strange. I mean, you'd think the gas giants would swallow them up, but the problem with that whole thing is that we know the second heavy bombardment happened because Jupiter moved backwards.
What an epic event.
And it just moving backwards, being pulled by Saturn into the spot that it's at now, just caused all kinds of shit to be thrown right at us. So, I mean, it's one of those things
coming through, what the...
Yeah, it's one of those things where it's like, you'd think, you would hope that it would swallow them up because it does a great job at it now, but back in the early days, not so much. It made these things happen, plain and simple. So regardless of how it was born, we was left with the treasure of the solar system, a huge moon, the largest in relation to its parent planet. Sure, it's not the biggest moon. Jupiter's Titan and Ganymede are easily twice the size of our moon. Those two are both larger than the planet Mercury, actually. That said, they pale in comparison to the great gas giant parent Jupiter. Our moon is a quarter of the size of the Earth. In fact, it's so big, some scientists call us a binary planetary system, which makes sense. Imagine for a second you're on our favorite exoplanet, Alpha Centauri B. You take a look into the telescope and you point it at us. It's highly unlikely you would come to the conclusion that that is a planet and a moon. It's far more likely that you would see two planets rotating around each other.
Yeah, I got to correct you there. It's Proxima Centauri B.
Oh, I'm sorry. I made an error.
We still don't know any planets around Alpha Centauri as far as I know.
We don't. I'm sorry, I made an error there. Oh, well, it happens.
The common center of gravity of the Earth-Moon system is still within the Earth's surface, which disqualifies it as a binary planet according to some definitions, which is, if you look at Pluto and Charon, which we're going to talk about later, they have in fact a common gravitational center that is between the planets, the dwarf planet then. So Charon should be a dwarf planet.
Yeah, which clearly makes them a binary planetary system. But, I mean, that's just, the size is so big of the moon that you would need to do in-depth study to find where the gravitational pull was of our moon if you wasn't in the solar system or knew. So you would look at it and immediately your first thought would be, it's probably two planets just spinning around each other because it's huge.
It's bigger than Mercury in volume, which is quite impressive. Bigger than all the dwarf planets. Only 4 moons in Titan, of Saturn, and Callisto, Io, and Ganymede of Jupiter are bigger. But yeah, as you said, the planet is huge.
Yeah, it's the area. It's kind of weird because when we say huge, there is huge as far as when you're talking measurements in space. One, you're talking like there's diameter, and then you're also talking, density and, and volume, and it's, well, what is it? But if you set them next to each other in volume, it's about 27% the size of the Earth.
That's enormous. In diameter, not in volume.
Okay, yeah.
But you could fit, if you could open the Earth and put moons in it, you would be able to fit in about 50 moons.
Yeah, something like that.
I think it's about 80 times the volume of the, Earth is 80 times the volume of the moon. But in diameter, yeah, when you look at it next to, if you put the moon over the United States, it would cover it.
No problem.
Cover the whole nation.
Yeah, no problem.
So it's enormous. I have to mention my favorite moon in the solar system, Europa. It comes in at number 6 among the moons, but it's significantly smaller than our moon.
Yeah, this thing is truly a treasure without being said, so.
We talked a lot in episode 1 about how Earth could be very special, and this is one of the most special things we know of. We still can't really see exomoons on exoplanets, but we don't expect to find a moon this big around exoplanets.
Absolutely.
We don't expect it to be very likely. We have so many moons in the solar system, and none of them are anything like our moon.
True.
Next episode, we'll look at Mars and see the tiny moons of Mars.
Oh, they're ridiculously small. Like, we're not even, compared to our moon, we're not going to spend they're not getting their own episode, I know that. Now, Jupiter's
No, they're definitely not. They're getting a small segment each.
They're going to get mentioned. So, our moon has no atmosphere, so regardless of whether it's day or night, the sky is always staring into the cosmos black void that we call outer space. The moon actually would make a great place to put a large telescope, to be honest. However, no plans are currently slated that I know of. Having no atmosphere creates other problems, though. It doesn't receive the protection from the atmosphere, and it has the scars to prove it. It's littered with them. There isn't any breakup of asteroids like we receive. They strike the moon whole, without resistance. Some of the early impacts, while the moon was still active, created what we call the seas of the moon, the Maria, which is just Latin for seas, to be honest. The world is dead now, we believe. There is no plate tectonics, so these craters, they stay put. It gets hit, it stays there. We can see almost all the impacts the moon has taken, well, at least on one side of the moon. And that doesn't mean that there isn't any mountains just because there's no tectonics. They're there. They're just formed differently than the way ours are. So the Maria, Dan.
Yes, the Maria.
Why do we call them seas?
We thought they were seas.
What?
Yeah, like early astronomers looked at the moon and said, "Oh, that looks flat. That must be seas." They are somewhat gray, but maybe the water is really muddy.
Yes, these are the dark spots on the moon. We call them the Maria. There's some interesting ones. There's some really cool ones. There's one ocean.
Yeah.
And there's a bunch of bays and everything else. And these were early astronomers trying to make sense of what they were seeing and not having the equipment that we have now. So they kind of came up with their theories, and well, you kind of look at what's around you and you project them. And they thought these things were seas, and all they really are is what?
Plains, pretty much.
Are they?
Yeah, the flat areas of the moon, the low-lying areas of the moon.
Okay. These things were created, impacts, hit the moon when it was young. And magma rose to the top, and much like you see over like Iceland now, it created this black, what's the word for that type of rock?
Basalt.
Yeah, it created a basalt, and it created a nice flat basaltic plain where it just, that's why it's black. They are kind of craters, but they were kind of filled in as well. So interesting enough, and very interesting is the backside of them doesn't have any.
That's very interesting.
And that goes back to it being slightly thicker than the front side, and that's a whole nother episode. But, strangely, one side of the moon has these, the other side of the moon, none whatsoever.
I think the tidal locking of the moon is one reason why we thought there were seas there, because the mares are so easily seen by the naked eye from the Earth And then you get, like, you start looking at the moon, and then that thing is not turning around. We can't see the other side of it. So then you start thinking, oh, what's it like up there? And eventually you end up with, oh, they must have oceans and seas.
Yeah, it's strange. I mean, it being phase locked the way it is. I use the term phase lock. He's using tidal. Both of them are correct, but tidal is more encompassing.
Yeah, we see a little more than half of it because of different angles and stuff, but it's not much.
No, it's one side facing right at us, and, you know, it's weird. They also came up with the man on the moon because, again, people project crap, and they see these things, and for some reason people see a man up there. I've never seen it.
No, I haven't seen it either, actually. But you could imagine the effect on ancient peoples, this gigantic thing in the skies of what the hell is that?
Yeah, I see a dragon myself when I look at the seas, but I don't know.
I could see a dragon there, yeah.
Yeah, that's what I see. I don't know. These things were very interesting. And as for the mountains, and the mountains are, we should, you know what, before we even get into the mountains.
Okay.
I do want to talk about, you know, the largest ones, like the Sea of Cold. All these things were named after things they thought the moon caused on us. So you have strange things like the Sea of Moisture. Yeah. The Sea of Serenity.
Moisture.
Yeah, because it messed with the tides. So the Sea of Moisture makes sense. The Sea of Tranquility, the Sea of Waves, again, the tides, the Sea of Vapors. The biggest one is the Ocean of Storms.
Sounds like fantasy names.
They are all fantasy names, but they're all things that at one time, like the Sea of Fecundity.
What's that?
The Mare Fecundus.
Okay, what's fecundity?
It is a rotting process. I thought you would know that from Magic the Gathering. It was it was a green card. Sea of Crisis. I mean, these things have some crazy some crazy names for these seas. The Sea of Cleverness, Sea of Islands. You know what I mean? Like, someone looked up there and went, yeah, that sea looks like it has a bunch of islands in it. So we're going to call it the Sea of Islands. Brilliant idea.
Who named these things?
Multiple astronomers back in the day.
Okay.
They started receiving these names 1800s. And people just came up with them.
Of course they did.
You know, is what it is. We have a lot of mountains on the moon as well. And by a lot, I mean a lot of mountains. And we have a lot of mountain ranges. And all of these were created how, Dan?
Well, they were created by I don't know how they were created. You tell me.
Every one of them was created by an impact.
Everyone?
Every one of them was created by an impact. Depending on how the impact hit, it could have pushed up one side, or you could have ringed mountains if it hit it directly.
All right.
So the mountains are all formed by just the way it was hit. So when you see the words like mountain ranges, like Montez Rook, which was named after an astronomer, Lawrence Rook, this thing, it's a range. So it's not like it's a perfect round thing. I mean, some of these mountain ranges, they are round. Plain and simple. But this one, it kind of has a straightness, I believe. There's even the Montez Alps. You know what those are, right?
Yeah.
Yeah.
Poor moon. It must have received such a beating.
Yeah, it has just been destroyed. I mean, everything you see on it is an impact from one point. And, I mean, the highest point is Mons Huygens.
Yeah.
And this is a mountain 6,500 meters high.
That's pretty high.
Wait, I'm sorry, my data was incorrect there. The highest point is located it's higher than that moon. The tallest point is Clementine. Data shows a range of about 8,100 meters from the lowest to the highest point on the moon. And yes, Mons Huygens is the biggest.
So it's hard to measure height on the moon because there is no sea level.
True. That and the fact that, like we said earlier, one side's thicker than the other.
Yes.
I mean, these are clearly mountains. You'd walk up to them and go, damn it, I gotta walk up that. But
yeah, and the lack of erosion means that the mountains will stay high.
Unless something hits them.
Yeah, to create new mountains.
That's the way of the world. Strangely, that world.
The way of the moon, at least.
The more I'm thinking about it, the more I'm thinking I'm calling the moon a world.
Of course it's a world.
The poor moon has been battered. It's been beaten up so much that the surface is covered in a talcum-like powder material called regolith. It's basically crushed rock. Very, very crushed rock.
Yeah, making it dangerous.
It's a real pain in the ass on our instruments.
Sure is. It's very, very, very small, so it gets in everywhere.
I mean, I'm sure if you've seen pictures of the moonwalk, and you believe them like most sane people, you saw the footprints.
Yes.
And, you'd think about it from your terms, and you'd go, well, yeah, I've walked through the woods on a muddy day and made a footprint like that. Yeah, but this isn't on a muddy day. That footprint was a perfect footprint. You could see every line in the boots, and there's no moisture up there. So it was just, and when I say dust, I mean dust.
Ultra dry, and no wind to move it around.
Yeah, for, just nothing. And you figure the best way to explain this to what regolith is, because we create it on Earth all the time. If you go to any rock yard, when I was a landscaper, I ran into this crap. And like where they tumble, rocks to create river rocks, believe it or not, every river rock and gravel you buy doesn't necessarily come from the bottom of the river. They can tumble them into that shape. But basically the best way to explain what the moon's surface is basically covered with is go into your medicine cabinet. Don't worry, I'll wait. Okay. While you're in there, grab the baby powder. All right. Got it? Okay, cool. Now what I want you to do is I want you to spill it out on your floor. Try to keep it in a pile though. All right. Okay. Yep. All right. Now put your shoe on. Trust me, you're going to want your shoe on. Okay. You got your shoe on. That's good. Now step in it. That's what walking on the moon is like. And imagine being able to leave that mark that you left with like zero gravity. I mean, yeah, there is gravity up there, but it's very, very little. This isn't a wet, rainy day in the woods. This stuff is very, very, light and beaten up. So it's a very interesting material. What do you think, Dan?
Yeah, I mean, as I said, it gets in everywhere. So getting rid of this and making the equipment you bring to the moon handle the regolith, it's really hard.
Yeah, I know during the Apollo missions where they landed, they did talk about that being one of the problems was that crap was getting into everything. And all of our lunar rovers that we've had, same deal. That crap just gets into everything and eventually beats everything up. So, I mean, but it's interesting because that just shows how many times the moon's been hit.
Yeah, and it covers the entire moon. It's hard to find naked rock. There is regolith everywhere. The thickness of it varies a lot, but it's present almost everywhere on the moon.
Yeah, pretty much the whole surface. I mean, some of the mountain peaks, you can find normal rock.
Yeah.
That's where you got to go. Think about that for a second. What we know is the moon is the only body in space that man has stepped foot on, aside from our own planet. We've seen many things there, but the most impressive, or we've sent many things there, but the most impressive is on the Apollo 11 mission. On July 16th, 1969, the United States sent a team to the moon. Then at 3:17 p.m. Eastern Standard Time, July 20th, 1969, the Eagle landed. Two of the astronauts, Mission Commander Neil Armstrong and Lunar Module Pilot Edwin E. Buzz Aldrin Jr. stepped on the surface of the moon. We have all heard the famous quote by Armstrong saying, "One small step for a man, one giant leap for mankind." Many, many missions have followed that, and many before came as well. Then in 1976, we just kind of quit going to the moon. That is until 1990 when the Hitin returned to the moon on behalf of the Japanese Space Agency, joining only Russia and the United States, and was the third nation to go to the moon. Its basic function was to verify future tech for future landings on the moon. We're not done going to the moon. Many missions are planned in the future, and there is some really space-agey stuff going on up there as well.
Yeah, getting to the moon was an epic event because we actually we managed to exit Earth's gravity. But it's a small thing compared to going anywhere else in the solar system because the moon is really, really close on the solar system scale.
Very much so. And I mean, the fact that we got there, I mean, we have to look at it as why did we go to the moon? Let's just take that one to begin with. And that was because of a war.
Yeah, it was because of prestige, pretty much.
I mean, the Americans would not let the Russians be better than them at anything because that would prove communism was better than capitalism.
And we could not have that, could we?
No, I mean, and not here in America we couldn't. It just, there was no way. And the Americans, my people, they took so much pride in, we had to be the first one because the Russians were the first one to orbit the moon. The Russians were the first ones to put crap into space. But America knew that if we got there first, if we put boots on the ground, as it's, often said, then we would be better than the communists. And they put more money into this than I think any scientific research ever since. This was important. The whole budget of the United States was behind it as far as they're concerned because it was a military activity in their eyes.
Yes, and so much good science came out of it.
So it shows what could be done with the proper motivation to do something scientifically, right?
Absolutely. It also sort of showed that there was really no point in going back all the time, you kind of know the moon when you have visited it a couple of times. You have those rocks. I think we have 180 kilograms of lunar rocks held by the US right now.
Yeah, they have plenty of rocks. But we're not done there. There's plenty of
we're not
going
done,
on.
but,
there's still orbiters, and there's mostly orbiters that are still there. There's Luna 25 is scheduled to be a lander, and it was scheduled to land last year, but I don't have a date on it actually landing, so I don't know what happened to that mission. Chang, it's supposed to return samples, so that's going to be a lander and a returner.
Yeah.
So, we're not completely done up there. I know you have some far-out ideas on what they might be doing.
Yes. The moon being so close to the Earth, it's of course a really big target for colonization. And when I was a kid, you sort of assumed that there would be a lunar base. I wrote a role-playing game in the 90s, set in 2051. And of course there was a lunar base. Why is there no lunar base? We have to colonize the moon. Some advantages then, of course, for the moon then, is that we are out of Earth's gravity. We are out of Earth's atmosphere, so we could do great astronomy, as you mentioned. A telescope on the far side of the moon could see very interesting things. If we could have space elevators, we could get material to the moon at quite a low cost and then build stuff outside of Earth's gravity, which would be very good. We have discovered water on the moon, probably put there by comets. But there is some water on the moon in ice. If you have water in liquid form, it quickly leaves the moon.
Yep.
But water as ice is there, so perhaps not enough. Another advantage then, of course, if you want to send more people, if you want to send more stuff, it's a fast trip. The Apollo astronauts got there in 3 days.
Yes.
We could probably do that much faster now. We could also, if you had you were saying?
I was just saying, yeah, probably.
Yeah.
Probably quicker than 3 days. I would think we could probably get there in 2 now.
Yeah, I think so too. Also, if you set up a colony on the moon and something bad happens, you could get help there in a reasonable amount of time compared to, for example, Mars. So Mars is more interesting to colonize because Mars is different enough. If something actually happened to the Earth, being on the moon is probably not the solution. But the moon is a perfect testing ground for Mars. The gravity is about half of Mars. So we would learn about the long-term gravity effects on humans. And I think that double the gravity of the moon is a lot better than half than the gravity of the moon.
Yeah, I've also seen, and it's not on the chart that I have with us, but I've read a study, I could have swore I did, where SpaceX, or one of the independent companies, is possibly talking about building one there. And the reasoning for it is it's a perfect launch pad.
It absolutely is.
If you want to go to Mars, it's a lot easier to get off of the moon than it is to get off of the Earth. And I thought when you started talking about the building, that's what she was getting into.
Yeah, it's like the perfect space station for Earth on moon. So like almost on Earth, but you're outside the effects of gravity, and let's just use this thing to be the space station, the orbital platform of the Earth. It's already there. Let's just build on it.
Yeah, it's just a perfect launch pad because, we can use our gas propulsion to get this stuff up to the moon. Assemble, something with ion sails or something like that on the moon and then just let it go. And
exactly. There is a lack of good building material on the moon, which is a problem. But another big advantage is the time to communicate. Because the moon is so close, you could maintain a normal conversation. You have a delay of 2 to 3 seconds. Whereas if people are on Mars, it takes some time for messages to reach Mars at the speed of light. It will take between 8 and 40 minutes delay between every sentence, so you can't maintain a normal conversation with someone on Mars. But you could on the moon.
Yeah, on the moon would be like talking on Skype to somebody, and on the Mars would be like texting with grandma.
Yeah, with the Alzheimer's grandma.
Yeah, I'll get around to answering it in a moment, and then they forget that they got a text, and, an hour later you get a text back and you're like, oh, okay, and then you shoot a text and then, you wait an hour and she sees it finally and she sends it back. I know everybody, not necessarily grandma, but I know everybody knows somebody like that, where it just takes an hour or so for communications to actually happen. It is what it is.
Also, of course, we don't really know the psychological effect on humans of not being on Earth. But if you are on the near side of the moon, you see the Earth. It's gigantic. It's 60 times brighter than the moon from the Earth. So maybe this would help with humans staying sane. It's like, oh, there is my home. It's close. I can get back there, hopefully. Yeah,
that's the one thing that, it's all hypothetical. We don't know if it would do anything to us mentally to be away from the Earth. I've heard hypothetical theories on all spectrums. We've been brought up on this planet, so we have an emotional attachment to it. Okay, but say the first generation that lives off of the planet, would they still have that emotional attachment built into their genes?
Probably not.
Yeah, we don't know. It might be in their genes. It might not be. Fear is something that is in our genes from when we had to run away from frickin' dinosaurs and crap. I know not necessarily dinosaurs. It's all right. Just put your letter down. I know. But there's a saber-toothed tiger over there. All right. I have a reason to be scared. It's going to keep me alive. Well, we don't deal with saber-toothed tigers anymore, but for some reason, fear's still there.
Yeah.
And it's in our DNA. So the question is, does that homesickness of Earth, will it stay with future generations or not? It might be actually mentally impossible for us to leave this planet because of that.
Yeah.
And I know that's really some strange in-depth crap, but that's kind of where we're at with that right now. It's awkward.
Yeah. And of course, as with Venus, the poles are attractive because you end up with this, if you're on the dark side, you never see the Earth. You have the lunar night is very long. But if you are at the poles, the water is probably at the poles, most of the water. You could also put yourself in a position because of the very small tilt of the moon compared. So there are no seasons and stuff on the moon. Well, you could put yourself in a position where you get 8 hours of sunlight per day if you are on the North Pole.
Yes. I don't know, like you said, there's no seasons. Well, without an atmosphere, seasons don't matter. What I mean? It's just not going to happen. It doesn't matter if there's seasons or not without an atmosphere. And as far as like the lunar day goes, we know how long the lunar day is. We watch it every night when we look at the moon. And we call it the dark side of the moon, but it's not actually the dark side of the moon. The dark side of the moon does get light. We just can't see it.
Yes, it's dark only in the sense that we can't see what's there from the Earth.
When we only see a very small sliver of the moon, that's because the sun's on the other side. It's just shining off at that part of it. The only time that, I know there's a misconception when you say the moon, when you see a half moon, that's not us covering the moon. That's just, we can see half of what the sun is touching. The only time we actually cover the moon is when you get what's called a blood moon. And that is a specific type of eclipse where we cover the moon goes all blood red. And Dan, you know the reason why it goes blood red?
No.
Oh, you don't? Okay, so this is because of our atmosphere and because of the way light passes through our atmosphere. Red light gets around us quicker and bathes the moon in red light because what happens is when the light's going through our atmosphere, it breaks up into a spectrum. And the red light gets to it before any of the other light does, and by the time the other light does, it's no longer under the effect of the Earth blocking it. So that's why. It's kind of like waking up in the morning and you have the red sky. Same deal.
There is a phenomenon as well. If you are on the mountains close to the poles, you could get eternal sunlight. For example, if you're on the rim of Shackleton Crater at the south pole of the moon, you could get the sun shining on you all the time, which of course is great for generating power.
Yes.
There are then a lot of disadvantages with the moon, even compared to Mars as a colony. Of course, the Apollo 11 astronauts were super lucky that they didn't get radiated to death. as we have no atmosphere, no protection from radiation, no magnetosphere of any size that's significant. So, and of course, these rocks keep coming. So even a small rock hitting a colony would be a total disaster.
Yeah, and by rock, you mean like a pebble.
Yeah, imagine like a tennis ball-sized rock coming at you at full speed.
I don't want to think about a tennis ball size because I can think what a BB-sized rock would do.
Yes, you built this like glass thing to make a human-friendly environment, and then one pebble just crushes it.
Yeah, one pebble going, about 14,000 miles an hour? Yeah, I think that's probably fair.
Ouch.
That's gonna destroy shit. Ain't no question about it. That would go through your house. Just think of it that way. A pebble going that fast will go through your house. And yeah, there's nothing to break it up on its way in. So yeah, that is problematic. We would have to come up with a way to deflect pebbles.
Yeah. Hiding beneath the moon's surface is of course one way to do it. Just like we are going to try to do on Mars, probably.
Ooh, regolith cave-ins.
Sorry?
That'd be cool. You'd have a regolith cave-in. You'd have to go out there with your bulldozer and push your hole back open.
The whole place is filled with regolith, but get this stuff out. But I think that there will be a lunar base, maybe in our lifetime at least.
I think so as well. Maybe because
you must want to do stuff like that.
Yeah, it's more for the practicality of it.
Yes.
Because, it costs a lot of money to get things in outer space. And what's the point of having, a chemical drive on something and just dropping it off all the time? Now that we're landing rockets, we can use that chemical drive to put the stuff up there, relaunch back, land our rocket, and then, build while we're up there for, future space missions. It just makes so much more sense. Because once you're up there, you don't need chemical force to take off. You can take off from a fart.
A very powerful fart, but yeah.
A human could go out and throw something. Like, could you imagine taking a paper airplane on the moon and letting it go?
There's no air to hold it up.
That's true. But it would just keep going, wouldn't it? Because there's not enough gravity.
I expect it to fall very slowly.
Okay, very, very, very slowly.
But there is one resource on the moon that is actually attractive. In the equatorial regions on the moon, there are high concentrations of helium-3. And helium-3 is rare on Earth, but you can use it in nuclear fusion research. So, interesting.
Okay, so the third generation of big bombs that'll destroy everything. Awesome! Let's do that.
Yeah, awesome.
Americans, listening to that? We can create a bomb even bigger than the bombs we have now. We just gotta go up there and get it. Put some money into it now.
There is a question then of who owns the moon, and I think the current agreement is that no one can claim anything on the moon. So if you have bought lots on the moon and stuff, you have been tricked. Because currently no nation or company or anything like that can own any part of the moon. The moon is owned by all the people on the Earth.
Until somebody puts up the right dollar amount.
I think until somebody puts a lunar base there, because they will claim that they own that lunar base, and then we'll have the moon war.
Yeah, once you establish that you're there, it's kind of hard to say, no, you can't be there, because you're there. Once you've built all the stuff around it, it's kind of like back in the day when the United States was moving west. There was a point in time where if you went somewhere and you built a house, guess what? You just got that land. And that's kind of the way the moon is, because no one owns anything on it. So if you go up there and you plant a stick and you build a house, guess what? Yeah, you own that. Put a fence up around all the stuff that you want to be yours.
Yeah, then we have the problem that you want to live on the poles, but all the valuable stuff is on the equator. So establish yourself at the pole and then try to build on the equator.
Yeah, build a fence to the equator. That way it covers your land.
So there's your tip for your plan to conquer the moon.
Yes. Build a huge fence the whole way around it. Wait, that sounds like somebody that's in office right now. Never mind.
Don't go there.
I'm not going to. So what we're going to do is we're going to take a real quick break, and then we're going to come back and we're going to talk about the fun, goofy stuff about the moon. And because so far it's been pretty factual, but we're going to get into the goofy stuff. Be back in just a moment.
Hello. Are you enjoying the show so far? I hope you are. Well, if so, I encourage you all to pause the show. Don't worry, we'll wait. Go to facebook.com/fan of astronomy and hit that like button. You'll be one of the first people to know when a new episode comes out. Also, on that page, the guys post articles on the latest news in the astronomy field and outer space in general. You also get to interact with the hosts of our show, Dan and Angelo, there, so please hit that like button on Facebook. Thanks.
Okay, so the moon over the years has had many superstitions and myths surrounding it. Some are completely crazy and dismissible, such as they make humans turn into werewolves. Others, however, like lunar transient phenomena, also known as LTP, aren't so easily dismissed. So what is an LTP? An LTP is a strange light that it just emits from the moon. These things have been seen as long as people have been looking at the moon. However, there has never been two independent observations of the same light at the same time. That said, we do see these. These do happen. There are a ton of explanations to these lights. None have been proven true or false to this point, but we do have some ideas as to why these occur, or rather should I say, why we see them.
So is there no TLP that has been seen by two different observers on the Earth?
Not that I have ever come across. I've looked into this.
Bad.
I've looked into this from multiple different angles. I've watched, believe it or not, I watched 3 different documentaries this week on LTPs.
Oh my God!
Yeah, and no 2 scientific researchers has ever been able to spot the exact same light at the exact same time. So there's a lot of different ideas on what this could be. One of them is it's our own atmosphere.
Yeah.
Just quite literally, it is a freak occurrence on our lenses from our atmosphere. Where
our atmosphere is a great problem when you try to observe stuff outside of it.
Yeah, but here's the problem with that theory.
Okay.
Neil Armstrong said he saw them when he was in outer space.
Oh, interesting.
So that it's like, wait a second, but if he saw a heavy luminous area, it was up at the northern Eridautes or something like that. I don't know. Some crazy region in the north, and this place is like a hot spot for it. And, which makes some people believe that maybe this one little area might be geologically active.
Oh.
Ooh, so that means the moon's not dead. But
go ahead.
But again, we have the same problem that no one's ever seen the same 2 lights at the same 2 times.
Have we had people at the same place seeing a TLP at the same time?
Yes.
So like Neil Armstrong showing Buzz Aldrin, look at that, and Buzz Aldrin going, oh, that's strange.
Yeah, he reported it back as they were orbiting it before they actually touched down. He reported back that he saw these lights in the northern area of the moon, and it's just like, and they're like, oh, okay. But like, we've never had somebody in, say, New York see it and somebody in California see it. Because if that happens, we know that that's going on.
Yeah.
Because there's...
So what are some other explanations?
Some other explanations is small impacts.
That makes sense.
Like a tennis ball. Tennis ball size rock hits, bang. Dust kicks up, we catch the light from the sun off of the dust, makes it look luminous, kind of seems like something that could possibly make sense. Another one is, believe it or not, landslides.
Landslides?
Yes, because we have these huge deep craters, okay? So let's say some of the regolith and some of the loose stuff on the crater slides. That's going to kick up the dust.
That would create a regolith cloud, right?
Yes. And said regolith cloud goes ahead and creates this imaging that we see. It's very weird, very cool. It can't be disproven yet. And we've been staring at the moon for how many thousands of years?
All the years.
All of them. Not some of them, all of them. So it's really, really a weird thing. Do you have anything to add about LTPs?
Well, it could be outgassing.
Okay.
We've seen, regarding impacts, we've made some human-made impacts on the moon, and they create these regolith clouds then, which, of course, if light reflects on them, it would create a light phenomena. But also we could possibly, as the regolith is so light, if there is outgassing somewhere, then regolith goes into the air as well. Into the air, not in the air. It goes up.
Yeah.
Also, perhaps it could be electrostatic in some way.
Okay.
But it's an interesting phenomenon.
It absolutely is. I know another one, when I say that it could be in our atmosphere, it could be like a rogue aurora that we're catching.
Okay.
Just strangely cause when you think of the aurora borealis.
Yeah.
You're used to the perfect lines. So who's to say that just a dot can't appear. And without the backdrop, it's so faint that without the backdrop of the moon's brightness, you'd never see it.
Ah.
But against that white shell, boom, it's right there. You can see it, not a problem. And these things, some of them last a few seconds. Some of them, they're said to have lasted a couple minutes. But never much longer than that because, again, we can't. If they did, we would have 2 observations of it at the same time. So, I don't know. I think they're neat. I think there's something that, when people say there's nothing left to learn about the moon, this just proves that there is stuff to learn about the moon.
Yes.
Okay, now one of the other neat, interesting things about the moon, and I'm sure you've heard this before, the moon
Yes, I have.
makes people go nuts. I mean, we have, I actually have a little thing here I want to read real quick. While LTPs seem to be legit, some others we just aren't sure of. Like, does the moon affect our mood? A lot of our ancestors believe so. The term lunacy and lunatic both derive directly from the believed effects of the moon on the human psyche. So basically, the idea was that if you was crazy, it was the moon's fault.
Blame the moon.
Blame the moon. So, I mean, like lunatic and lunacy, they're both named after the moon. I mean, it derives directly. Let me finish this little bit, and then we'll just go over all 3 of these topics at once, because that makes more sense.
All right.
Okay, so we also have some more anecdotal areas. Both police officers and medical professionals around the globe will swear to you the moon has an effect on us. They will tell you that ER visits increase during a full moon. They'll also tell you that major crimes occur during a full moon. These are strange. They have never been proven to be 100% true, but the amount of studies on this is small, so no factual conclusion can back either of these up. There have been studies that says that it is true, but again, it's so few, you cannot call this fact. Okay, so what you think there? I mean, I know some nurses who have told me flat out that when the moon is full, the ERs fill up.
Yeah.
And I have police officers who tell me that when the moon is full, crime rate goes up and they're running around like crazy. So let's say that's true. Why?
Yeah.
Why would that happen?
If it was true, it would be interesting. I'm looking at a study from 1996 by Ivan Kelly, James Rotten, and Roger Calver that was pretty extensive on lunar effects. And their conclusion was that the studies failed to show a reliable and significant correlation between the full moon or any other phase of the moon and each of the following. And here is what they looked into. Homicide rates, traffic accidents, crisis calls to police or fire stations, domestic violence, birth of babies, suicide, major disasters, casino payout rates, assassinations, kidnapping, aggression by professional hockey players, because there's statistics for that.
Okay.
Violence in prisons, psychiatric admissions. But here is actually one study that showed that psychiatric admissions were at the lowest during full moons. Agitated behaviors by nursing home residents, assaults, gunshot wounds, stabbings, emergency room admissions, behavioral outbursts of psychologically challenged rural adults, lycanthropy, vampirism, alcoholism, sleepwalking, and epilepsy. But they also addressed why people would think that the moon affected these things. So they put it down to 4 factors: media effects, folklore and tradition, misconceptions, and cognitive bias, and possibly communal reinforcement. Because it does feel special, right, when you walk out and see a big fat full moon in the sky.
It does. And I have read studies.
Yes.
And I am actually trying to pull one up now. It was from 2006, the University of Berlin in Switzerland. And this is why I think all this stuff happens. And what they concluded in their study, and it makes sense. Here's the deal. This goes back to what's in our DNA. During a full moon, you can hunt. So our ancestors stayed up later during full moons because they could still hunt. And that DNA is still being passed down. So crime rate goes up and ER visits go up because people are awake. Shit happens when people are awake. People don't sleep as well during a full moon as they do during the dark moon because it's just in our DNA to, go out there and do stuff during full moons. So when people are up and out doing crap, shit happens. That's just, if you take a group of 10 people and you look at the crime rate of 10 people, it's going to be lower than if you have a group of 1,000 people in the same area.
Yeah.
So I think that is the explanation behind all of those. That's my personal opinion, but it also makes that, hey, maybe these are kind of true. I don't know about the mental health thing, but the crime rates in the ER visits, I believe. And I believe it because of those reasons. If more people are out, theory. More shit happens. Yeah. And I thought.
So my special feeling when I go out and look at the full moon is that I want to hunt mammoths.
Yeah, or deer or anything. I mean, realistically, until the age of farming, which, I mean, you know,
when you have to go to bed at a boring time to get up early enough to farm.
And I'm not talking like animal husbandry or like wheat growing. I'm talking like mass farming. When people still had, before that, people still had to go out and hunt for their food.
Yes.
I mean, we're only talking a couple hundred years ago we broke this cycle. So it's something that's still with us. And I mean, it all makes sense to me that, yeah, ER visits are going to go up because people are awake and you're out doing stuff. And, you know, a full moon is like a Friday night, man. You know what I mean? Like on a Friday night, more shit's just going to happen because more people's out.
Of course.
So, but there are some truly wild stuff. Dan mentioned a couple of them there.
Werewolves.
Werewolves. Vampires. I mean, some of the gods in ancient times were the moon.
Yeah.
You know, it's like, and these are just people just way out there on their imagination. These things, none of these things are real, but man, like the one with werewolves, that's a funny one when you really stop and think about it. Like when you heard it as a kid, like I know I heard it as a kid and I was like, ugh. But then as you get older and you actually like stop for a second and you like, you know, actually analyze it and go, wait. So what you're telling me is when that thing's in the air full, all of a sudden some humans turn into dogs.
Yes.
Why the hell did anybody ever believe that?
That's a good question. I think just in ancient times with this, you are so bored. You try to survive and stuff, but you have these two enormous objects in the sky and you just, and they're common to all people. Like everybody knows about them. And if you're going to make stuff up, you're going to make stuff up about the sun and the moon, which you have no chance of explaining. You have no idea what they are.
Right.
So your imagination will fill in the blanks.
It will. I have another quick thing that I want to bring up, and the moon, for you people that go outside and you look in the sky, when the moon first comes up, it's no bigger than what it is when it's completely overhead. That is an optical illusion.
Yeah.
Okay. It's, there's a theory behind it. But basically it's the same one that says if you were, it's about depth perception because you have things in front of it to measure it against. It just seems bigger. You know, it's kind of like if you were to look at train tracks going down a train line and you were to draw some lines on it, the same size, the ones in the back would look longer than the ones in the front. Because because you're just staring at the train tracks. The same thing happens. I'm sure you've all seen the videos on YouTube of cars in neutral going uphill.
No, I haven't.
You have not?
No.
No? Oh man, you gotta look those up. But all it is it's an optical illusion because you're seeing the hills behind it and you're assuming the road's going up when the road is really going down. But when you put everything into, effect, it creates this crazy optical illusion. I'm trying to find the name of it.
I know what you mean. Our brains are hardwired to interpret our environment and, sometimes we put them on interpreting stuff that they are not made for, so we get the wrong interpretation.
Yeah, but I mean, if you were to take a pencil or take a ruler, it's even better. And you were to take a ruler and you were to hold it up first thing, as soon as the sun was up in the sky, or the moon was up in the sky. And let's say it came up to 2 inches because of how far you're holding it away from your face.
Yeah.
And you were to take the exact same ruler a few hours later when the sun is in the middle of the night sky and nothing's around it, it's still going to say 2 inches. But
I hope the moon is in the night sky, not the sun.
Yes. I'm sorry. It just...
Sorry.
Dan. These people knew what I mean.
Yes.
It's just one of those things. It kind of happens. It's still going to be the same size, but it's an optical illusion. So for anybody out there who does look at the moon in the, you know, when it's just above the horizon, yeah, it just looks bigger to you.
It makes complete sense to me because you see like, oh, there's the moon right next to the water tower and the trees. Like it looks enormous. But then in the top of the sky you see there's the moon and it's kind of bigger than the stars and you have no references. So
yeah, it's just this tiny thing.
Just looks tiny. The sky is big and the moon is small compared to it.
Yeah, it's one of those weird things our brain does with us. So guys, we have no iTunes reviews this year, but I do beg you to go over to iTunes, hit that 5-star button, leave a comment, and we'll read it right here on the air. We are also now available on Google Play. So
yes, and on a lot of Android apps. But if you have a favorite Android app for listening to podcasts and you can't find Fan of Astronomy, you have to tell me and I will make it appear there.
Yeah, he will make me make it appear.
No, I will make it. Yes, Google Play is like illegal in Sweden, so
yeah,
I couldn't do that. But most Android apps I can.
Which is weird considering they sent the email to you. I'm like, I thought it was illegal there. Why are they sending him the email? Anyway.
Yeah, I think their policy of not allowing Google Play in Sweden is super strange.
Yeah. So Google Play is available now. So for you Android listeners, it's there. So if you find us on YouTube, where you should be hitting that like button and commenting and hitting that subscribe button as well. If you just want the audio version that you can take with you and you have an Android, go ahead over to Google Play and check that out. Yeah,
and if you are on YouTube as well, you have some bonus content, including 2 more interviews with Clues.
Yes.
If you like him, check out our YouTube.
Yes, those were from way back when I was doing a podcast called The Imps Prison.
Yes.
Yeah. So, Dan, if people wanted to get a hold of you, how would they do so? Smoke signals? Ooh. How about a giant balloon and a
in Sweden, we usually communicate by attaching a letter to a polar bear and telling it to go somewhere. But if you don't have a polar bear, you can find me on Twitter at Dan Horning. You can find me on YouTube on Dan Hörning. You have to put 2 dots over the O because you can't do that on Twitter, but that's the way my name is spelled, really. I'm also on YouTube, on my personal YouTube channel with the same name, where I have been challenged by a British YouTuber to do a video blog every day, so you can find weird stuff about Sweden and podcasts and things there on my personal YouTube channel.
I don't know if I do took that challenge.
It's more difficult than I expected, but I'm still doing it every day, so where can people find you?
They can find me by going to the bottom of the ocean, okay? Once you get there, you hang a left, alright? Once you hang that left, you're going to see a cave, okay? Inside that cave, you're going to go inside that cave, and you're going to follow that cave to where you hit the lava. Then you're going to follow the lava back up to the surface, okay? Once you get to the surface, you're going to pull out your cell phone. From there, you will go to twitter.com and put in Gonksuo or FOA Angelo. Both of them are me. Go right ahead. You can also find me on that same phone or even on your computer at Fan of Astronomy, Facebook.com/Fan of Astronomy. I'm there. I'm going to try and post more often. After the show's over, I'm going to propose something to Dan that he's not going to like, but he's going to have to help me do it.
Oh my God.
But those are the best places to find me. And, I am pretty open to talking. Again, I told you guys last week, if you go to the Gonksuo account, GANKSUOU, do not expect me to hold my tongue. I am very opinionated, loud, and use a lot of 4-letter words. So, you've been fair warned. So next week, Dan, we're going to go over Mars.
Yes, we are.
Or not next week, in 2 weeks from now.
In 2 weeks, Mars. Interesting place.
We're going to talk about, everything you can think of, from little green men all the way to the actual real things that go on Mars. So please.
Like canals.
Yes, canals. Yes. Please join us then, and we're going.
But before you do, send us an email as well.
Oh yeah, I forgot about the email. That's right, because last week I said the wrong email address and I said you'd fix it in the post. I was drunk by the time Clues was done.
What's the right email address then?
I don't remember. FOAcast@gmail.com.
AOFcast, right?
AOF, yeah.
It's the wrong order of the letters.
Yeah, AOFcast@gmail.com.
Send us questions. We'll answer them in cast.
I could have looked it up right here on my screen and I didn't. It is, in fact, AOFcast@gmail.com. We will answer anything you want to know about Mars. If you get the question to me within I don't know, 3 days out of our recording time, which is actually on the Monday before you hear it, we will go ahead and we'll fit it in as much as we can. If it's a really good question, even if it comes after, I'll make him get online and talk to me for 5 minutes, and I'll stick it somewhere in the show.
Sweet. You can also ask us questions about the asteroid belt or Jupiter.
Or any of its 50-plus moons.
Yes.
Because the moons are going to get a show, some of the moons are going to get their own show, and Jupiter is definitely getting its own show.
For sure.
I would hope. It's like the biggest thing in our... Never mind. It's really big. So, join us next week when we go over Mars. And remember, if you have any questions within our solar system, please send them to us because we will do that. But until we talk to you again, I encourage you to continue to look into science. It's very important for us all. And every time you turn around, something new pops up that you didn't know, so you can constantly learn.
What'd you think? Did you enjoy it? Well, if you did, head on over to patreon.com/astronomy and pledge to these guys. For each patron they receive, the more they will be incentivized to improve the show. So help them out so they can help you out and throw them a couple bucks an episode. They will really appreciate it. Thanks.